We're pleased today to have Mark Scarboro from NHTSA. He's the Crash Injury Research and Engineering Network Program Manager for NHTSA. That's a pretty cool title. And then he's also the co-chair for Transportation Safety for Older People Committee, and a chair for Abbreviated Injury Scale Content Committee for the Association of Advancement of Automotive Medicine. He joined NHTSA in 2003. Before that, he spent 12 years in injury research down in Baltimore. So my role here is just to be a facilitator. I'm going to let Mark do the heavy lifting, but certainly our office, we collaborate quite a bit with NHTSA and also with Mass Department of Transportation. We have our own highway safety plan, and we try to make sure that it meshes properly with the 5-year strategic plan that MassDOT does, and I think Mark's going to talk a little bit about some of that stuff. So with that, Mark Scarboro.
Thanks, Art. Thank you. You should hold that till you have to see the slides, and then you can decide. I'm here from NHTSA. I got quite a few slides, pretty big talk since I'm the only presenter for this whole session, so I got a lot of time to cover. Thanks, Bonnie. So with that, let me get started. So NHTSA, the agency I hail from, it's a pretty small agency. We have a little less than 600 FTEs and a budget of about 820 million a year. That's 820 million, but in federal government, that's a small budget. But we're responsible for the safety of passenger vehicles, about 250 million of them in this country. So we have a pretty big task ahead of us, before us, and we actually have a lot of other tasks besides just safety of vehicles. Our workforce is very diverse and quite professional. NHTSA is really kind of composed of 3 segments. The National Highway Traffic Safety Grants side has the biggest chunk of the budget. You can see it's about 68% of our entire budget goes to them. That money goes basically directly out to the states for the state highway safety plans, as Art was just mentioning. The other second group is the National Safety Research and Development Work group that puts out things such as nationwide campaigns. Click It or Ticket is probably their most popular thing that you guys have seen. That's their work. And then there's the vehicle safety side, which is where I hail from. Our side of the shop is responsible for coming up with the safety standards for all vehicles that will be sold in the United States of America. So why are we here today? We're here for older driver safety. NHTSA recognizes this as a growing concern and a growing issue. How did we get here? Well, at the conclusion of World War II, soldiers came home and got back to life. When they got back to life, we had the baby boom of the mid to late 1940s and 1950s. Old U.S. Census Bureau data shows you that nice big tick up, I should say, in birth rates in the United States. And you've heard the silver tsunami call, so this is what that data started to look like for us currently. The silver tsunami. It was already used this morning. It's a very popular saying for what's going on. But this is a popular graph from the U.S. Census Bureau showing that the population of 65-year-old and older portion of the population is going to grow and grow tremendously in the future. We all know this. We've seen this for a while. But the transportation safety aspect is a perfect example of an area that's going to require a lot of attention, and we need to get busy now. So NHTSA has devised a plan. We worked on the plan for almost 2 years. We feel it's robust and well-rounded. The desire was to develop a plan encompassing all parts of NHTSA as opposed to each part of NHTSA coming up with its own plan for the problem and kind of stovepiping things. We wanted to make sure that if we could have some interrelations with our other partners and work with the states through our other groups at NHTSA, we wanted to make sure we could do that, and that's what we did within the plan. Plan's comprehensive. It's a 5-year plan, by the way. It's actually it's greater than 5 years. Published December of 2013, so it's not that old. Comprehensive. It's built on what NHTSA can do. It's built on our strengths. It's designed to be flexible, and we build it to grow on the progress that we make. So as we make discoveries or setbacks, we have to adjust the plan accordingly. Development of the plan. So the first thing we had to do was put together a team. And we wanted the team to be multidisciplinary. If we wanted this plan to work across all parts of NHTSA, we needed people from all parts of NHTSA. So we had researchers, psychologists, behavioralists, engineers, and other folks on this committee. The committee was about 24 strong from NHTSA. I was one co-chair, and S.E. Wagner was my other co-chair from the behavioral side. One of the things that we wanted to do was look at the data and figure out from a current literature view what we knew and what we didn't know. We wanted to discover those things that we felt that we didn't know that well, weren't that confident with, so that we could put that into the plan to have more work done in that area. The four big areas that came out from our work in looking at what we knew and didn't know became the four main areas of the plan, which is data, behavioral, pedestrian, and vehicle safety. And so far today, everything that was presented in the kickoff sessions was driver, 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 driver. And we looked at drivers, but we looked at everything else to do with the older folks, whether they're a passenger in a vehicle, whether they are walking and they become a pedestrian statistic, looking at all the behavior that relates to all those, as well as all the data that we currently collect and what we needed. So from my talk, we'll cover more than drivers, just so you know. So for each major area, we had needed to come up with our near-term, short-term, and long-term plans of what we were going to do. And each one is built on what happened. So in near-term, we'll decide what we're going to do in the short-term. So some things that, again, to be flexible and to be able to adjust the plan over time was the idea. So near-term is really about 2 years. Short-term was running out 2 to 5 years, and long-term is 5+. So right now the plan is in near-term, things that we're currently funding and are currently doing. We also held an expert workshop after we got a initial draft of the plan pulled together. We pulled in, similar to what you guys are doing here today, NHTSA pulled together a workshop of experts from across the country and went over our findings and where we were kind of headed and got their input on our ideas, and some of the input that they had revised the plan. Finally, we finalized the plan. It went around for agency review and was published in December of 2013. So our data, looking at our data, the red line are all fatalities from the FARS database. Looking at this, we've done really well at bringing down fatalities for overall in the red, but you can see we pretty much are flat for the 65-year-olds and plus. We don't see as dramatic impact for the older folks as we've seen for the population as a whole. I've updated that chart with the first chart was what was in the plan. This chart has 2 more years of data added to it. We saw a little upkick in 2012 in the overall numbers. Can't really explain that because in 2013, the numbers for overall came back down to about where they have been plateauing for several years. But the scale's hard to read on this, and I apologize because it's covering so much data. But if you notice, the white line is starting to tick up. And if you can appreciate the scale, you don't want that tick. If you can notice a tick up in that white line, it's not all that impressive. So again, looking at all older occupants in a vehicle, drivers, right front passengers, and people who are sitting in the second row, or if it's a minivan, the third row, or an SUV that has 3 seats and so forth. Looking at their relative risk from our data, from our crash data that we collect out in the field, you can see that breaking out the ages, our base was 35 to 54, which set us at a relative risk of 1. Now comparing those that are 65 to 74, those that are 75 to 84 and 85 plus, comparing those back for relative risk, you can see that drivers have a higher risk at 1.8, 1.7, and 1.77 for the driver and the right front passenger and row 2 passenger, row 2 plus I should say, pardon me. That's drivers. That isn't all, that's a raised risk, and that's not good. It's higher than 1. But when you take a look at your right front passengers and your older people sitting in row 2 plus, you see numbers of relative risk increase of 1.5, 1.6, and 5.04 for those age groups. 5.04, 5 times higher for those right front passengers, 85 plus. And then if you look at row 2 plus, you're at 1.4, 2.2, and 3.1 times greater at those age groups. So drivers are doing pretty good in the newer cars. Why? There's a lot of safety bells and whistles for a driver. What do we test for at NHTSA? Drivers. What are the cars built for? Pass the test. Protect the drivers. Passengers don't have exactly the same setup. They don't have a steering wheel in front of them. Okay, that actually changes how their bodies are loaded in a crash. And then row 2 plus, really, in a frontal impact, your only safety device is your seatbelt. And in a side impact, you may or may not, depending on the make model of the car, have a side airbag available to you. There's not that many side airbags available in row 2 and row 3 of vehicles. We updated it with 2 more years of data. I did this for all of the standard graphs that were in the standard stat runs that were in the plan. The numbers have come down. We have newer cars in our data set, so we do see all of them. They're still high, but they are coming down. But still, 85 plus for your row, right front row is 4 times greater. Pedestrians, this was in the plan, this is the data. It basically simply states that a large segment, over 20%, or about 20%, are over 65 for pedestrian. So that's an area that we wanted to make sure that we focused on in the plan. And the data backs that up. One overarching thing that was throughout the plan, we have a couple overarching that touch all points of the plan. One of them is defining older. What is older? For years we've used 65 plus. We know better now. That's not older. It can be older for certain problems, but it may not be older for other problems. So one of the things in the plan does is basically say that for at-risk, we need to figure out what older really means by each one of those segments of the population by age. So we need to, we have the answer for this will have implications to all parts of the plan. It gives answers for this will give us the ability to properly assess age in relationship to the problem that we're looking at. We're currently collecting real-world injury data and injury causation data in the near term. We're looking at those contributing factors that make the injuries more severe in the older folks or more likely in the older folks. We're doing computational models. We're building computerized models of the human, and we already have one for a 50th percentile healthy male. We're now building one for an older male, and I'll show you some of this in later slides. But we need to look at how age changes your body so that that computational model will be accurate, or as accurate as it can be. And we're looking at driving performance assessment in the near term so that we can do the research on age and age-related conditions that's going to affect those assessments. Defining older, in the short term, we will, again, you're going to hear this throughout my talk, is that we will build on what we get from the near term. That was clear in the plan. So what we discover in the near term, we will have to do assessments and analysis on what we find in the near term to decide what we're doing in the short term. In the long term, NHTSA's goals are to include and refine age-specific issues and assessing process and data needs to improve implementation of programs and research. You'll notice that I read a lot of slides when it's on the behavioral side because I don't do behavior, so I got to go with what my folks on the behavior side told me to say up here. When we get the vehicle, I'll be a little more comfortable. Data, one of the legs of the table of the plan, essentially, one of the 4 columns, data. And why is data so important for us? All the decisions we make, the first thing we do is we go look at the data. We're data-driven at NHTSA, and data is very important to us. But that being said, improvements are needed. I'll run through this really quick because we have a lot of data systems at NHTSA. A couple have already been mentioned this morning in some of the other talks. We have FARS, the Fatal Analysis Reporting System, nationwide census of all motor vehicle-related crash deaths. The General Estimates System, GES as it's more commonly known, nationally representative sample of police-reported crashes. We sample about 50,000 of those per year for that system. The National Automotive Sampling System, better known as NAS, is a nationally representative sample of investigated crashes where we actually go out on about 5,000 cases, photograph the car, measure the damage to the car, go to the scene, do a scale diagram of the scene, and also record the injuries for all the vehicles in that crash and the occupants in those vehicles. We have Special Crash Investigation, which is known as SCI. They tend to get the hot topic issues. They tend to go out on a moment's call. Things like defects investigations, Takata bag would be a good example right now. Unintended acceleration a few years ago would be another good area that SCI would have been called out. They chase down the newest technology is really what they kind of do. They'll also chase down injuries that don't seem to make sense. Injuries, the group that is my group, Crash Injury Research Engineering Network, we concentrate on the newest cars with all the bells and whistles that you still get injured in. Those are the when you have airbags and you got your seatbelt on and you're doing everything right, but you still get a serious injury. Those are the cases that my group is going to take a look at. And we have NHTSA, which is not in traffic surveillance. backing over kids in driveways, and parking lot crashes. Those don't make any of our other systems, with the exception of Siren does them and NHTSA does them. So if there's a crash in a parking lot that causes a fatality, it's not going to be investigated by one of the other systems. So data, what are we going to do with data? Since everything we do is based on data, we really have to, we spend a lot of time in the plan figuring out what we need to increase our collection on in data. All of our data systems, again, it's an overarching need for all the other questions that we were asking in the plan. And one of the things that's going on currently at NHTSA is there's a huge data modernization going on for all of our data systems, and it was a congressional mandate. They said update your systems. They haven't been updated since the 70s. You need to get with the game. So we are under a mandate to update all our systems. We're currently doing that. We are looking at a new sample design for those that are based on sample. We are using more modern technology for collecting data. We used to measure cars with gauge rods and tape measures. We will now be using laser scanners to measure our cars. And we will be using the laser scanners to record the scene instead of roller wheels and tape measures, which is currently still what we use, believe it or not. And also exploring new data fields that we need. So looking out at users of the data, and there was a public question and answer session for this data modernization several years ago as to what we needed, and many folks commented on the data we needed to collect to improve our data systems, and we are, as best we can, are trying to put all those into the new data systems, and a lot of them had to do with older folks. And again, this all is going to relate back to the near term, short term, and long term of our plan. Areas of need in data, some of the ones that were mentioned when we met with the public and the advocates. Crash causation. What actually causes the crash? What age-related conditions are causing these crashes to happen in the first place? And we're working on that, but we got to be very careful with culpability. We can't point out anybody's fault. That really doesn't work well, because then somebody takes it to the court of law, and then we are either helping or hurting somebody, and we got to be very careful with that. So we can still capture causation, but we have to make sure that you can't identify that person. So we have to work very hard at sanitizing our data, and through any measure, you can't work your way back and figure out who we're talking about. Injury causation, accurately assessing the factors of age that make injuries more likely or more severe. Adaptive equipment. As more older folks keep driving longer, we're going to see more adaptive equipment in these vehicles. And these are things that are added on aftermarket. Okay? Are they functional? And are they safe? Is there an injury risk with these? If you've seen a car with a lot of adaptive equipment in it, there's a lot of bars sticking and levers and wheels and pulleys, and so how does that work in a crash? That's something we're very interested in. And again, we got to get more data on those off traffic way crashes. A lot of the older folks are in parking lot deals. Behavior. Bear with me, I'm not a behavioralist or specialist or anything, so I'll just run through this. So, but it was probably the biggest part of the plan, honestly. It's probably a good 60-70% of the overall plan of what NHTSA intends to do. So, emphasis on older driver age-related functional changes, explore methods to identify risky drivers, provide training and support to drive safely, limit or cease driving while addressing those people's mobility needs, and education and support cannot just be limited to the older drivers. You got to let the other folks who are going to interact with these older drivers be aware of what their responsibility and courses of action are. Study just came out a little while ago from NHTSA, from the NIMVICS data, the National Motor Vehicle Crash Causation data. 94% of all crashes are because of driver behavior. Not rocket science. We know that drivers cause crashes many times. This should probably, for the behavioral folks in the state highway safety offices, is familiar to you, but it is a core of the behavioral segment of our plan. It is the Highway Safety Program Guidelines, number 13 from NHTSA, which deals directly with older driver safety. In the near term, the whole plan is built around promoting HSPG 13 to the states. In the short term, we need to assess how HSPG 13 worked in the states. How did your programs fare? Did you meet your numbers? Did you not meet your numbers? And in the long term, assess those changes. Maybe we need to change the guidelines. Maybe we need to work in those guidelines. But that really is it in a nutshell of what we're going to apply for the states to follow by. And we're going to push the states to follow these guidelines. We think they're well designed and robust, and HSPG 13 is a huge part of NHTSA's 5-year plan. Real quick, what's in HSPG 13 for those who don't know it? It calls for a comprehensive state safety program through program management, roadway design for older drivers, driver licensing, medical provider interaction, law enforcement interaction, social and aging services providers interaction again, communication program, getting the word out, program evaluation and using your data. Okay, take a look at the data, figure out what the data is telling you. And program recommends key components and criteria for those components that need to be met. Okay, HSPG 13, pretty huge component of the overall program that NHTSA put together for the states. Communication. Again, getting the word out from NHTSA. This isn't from the state side. This is what NHTSA needed to do from a communication standpoint. And our biggest communication tool, of course, is the internet. So we have an older person safety page on our internet. It looks at older drivers, medical. It's out. There's information for medical providers. There's information for law enforcement, researchers, caregivers, and a host of others. It really works to help identify those medically at-risk drivers as opposed to just everybody over 65 needs to be looked at. Okay, we're trying to avoid that in the short term, sorry. And in the long term, again, assess what we've done, assess the communication we're putting out there, and decide what we need to change and what we need to add. One thing I'd like to show you here, and I've got several videos today, lots of eye candy, is a video that is part of the web page. It's called the Video Toolkit on Medical Conditions for Older Drivers. And if I can get my cursor back. All right. Bear with me. Shoot.
We can see it on the screen.
Oh, can you? Oh, okay. That helps. Thank you.
Most older adults are safe drivers. But sometimes, health problems make driving risky or even unsafe. Some medical conditions, such as arthritis, Parkinson's disease, diabetes, or a stroke, can cause some serious changes to the way our bodies move and process information. Certain health problems can make even simple motions, like turning your head, more difficult. Some health problems can change the way you see, increasing your chances of causing a crash. Other health conditions can affect your short-term memory or limit your ability to think clearly and can ultimately make driving unsafe. Not every older adult with a health problem is an unsafe driver. There are options that can assist you in staying safe on the road.
Since we're not sure.
A driving rehabilitation specialist can recommend adjustments to your driving or your vehicle to keep you safe behind the wheel. This video series explores many common medical conditions and how they can affect driving, and provides information and resources on what you can do to stay safe on the road. Talk with your family and have a plan for when it is no longer safe for you or a family member to drive. The car is only one way to get around. Stay safe for yourself and for others on the road.
So that's one example of our communication tool, okay? And you saw the list of medical issues that are specialized for each. There's a video specialized to each one of those medical conditions. The one I showed you is the overall summary. So back to behavior in the plan, limits of assessments, okay? No one test fits all. This is very well trumpeted from NHTSA. In the near term, NHTSA is going to work with states on developing assessment protocols. In the short term, NHTSA will conduct clinical and naturalistic driving studies to learn effects of age-related medical conditions on driving performance. And in the long term, NHTSA is going to work towards identifying performance measures that may be used to predict crashes. Again, that's long term, and we'll assess that with what we learn in the near term and short term. Indicating at-risk drivers is not always an easy task. Okay, driver's licensing, referrals, and communications is a huge issue, as we know. Again, in the near term, NHTSA will be working with states to improve DMV's positive influence on safety by restricting or suspending licenses appropriate. Improving awareness to potential partners, again, our medical partners, the law enforcement partners, and caregivers next to kin. We got to get the word out. Promote training for DMV staff to better recognize and refer potentially risky drivers and get them in front of a medical review board as appropriate. That's in the short term. And again, in the long term, assess what we've done in near and short term and make changes as necessary. Pedal application errors. Big in the press a couple of years ago, and it continues. Currently, we are screening complaints alleging misapplication from the field. We do get those complaints in. We do investigate those types of crashes when the word gets to us, but unfortunately, not every misuse gets up to our level, so we can take a look. We are going to, in the near term, also going to initiate research on behavioral issues related to pedal misapplication. Short term, we're going to initiate work on behavioral countermeasures, and the plan looks to evaluate those behavioral countermeasures over the long term. Adaptive equipment. Spoke a little bit about this in the data section. As you can see, if you look at the picture on the lower right, you can have quite a few bars, hinges, pedals, levers, things on a heavily adapted vehicle. So we know this is going to be a growing concern. We want to get a better idea of how many pieces of adaptive equipment are out there in the fleet. We really don't have a good idea of that. We work with the National Mobility Equipment Dealers Association, and we're working with them to try to figure out a way to get an idea of those numbers. We're going to continue, and we have for a while, been looking at field cases where we find adaptive equipment in the vehicle and see how it performed and if it was at all an injury risk. And again, short term, working with NMEDA, if there's a quick one for that, thank you. And monitoring and assessment again for our long term. But as this older population grows, and it will grow, we expect more and more adaptive equipment in the fleet. But we really don't know its true influence. We know that it's influential in helping people drive, but there's another side of the coin that we got to be aware of. Pretty straightforward with safety belts. Put them on. Belts are better than no belts. And we have, sometimes with the older folks, we have some trouble convincing them of that. So in the near term, just keep pushing the message. Put your belt on, ladies and gentlemen. In the short term, this is a pretty big issue for how a person loads during a crash, is putting the belt on right, okay? Up on your D-ring, when you get in your car, the belt that goes across your shoulder can be adjusted up or down, okay? It's very important to get that adjusted correctly. You want that belt right across your clavicle, right across your collarbone, okay? And if you take time at walking through Boston or wherever you might be, at an intersection, see a lot of cars come through, just glance. Just glance and see how many belts really aren't where they should be. Up on the neck, hanging over the edge of the shoulder. You'd be amazed how many belts are in the wrong place. So more education on making sure the older folks know, get your belt on right. Long term, again, monitor what we're doing and see if it's working. Pedestrian data, second leg of the table, second column of the plan. Pretty straightforward here. We need to, we know the numbers are big and they're getting bigger. Okay, the numbers have been going up over the recent years. We need to improve the data. We need to look at the technology that's available, and we got to educate folks. The end goal, though, for any pedestrian, but especially for the older folks, no contact. Don't let the vehicle contact an older person, okay? They don't do well getting hit by cars. Younger people don't do well either, but they recover better and they're more tolerant. Older folks, just no contact. Let's keep the vehicle and the occupant apart. Pedestrian. So again, nearly 20% of pedestrian fatalities are over the age of 65. NHTSA belongs to what's called the Global Technical Regulation, or known as the GTR around our shop, for pedestrian injury mitigation. We're doing things at looking at leg form testing, which is the picture down at the center bottom. We are running tests, and we're also looking and running tests on hood stiffness. Okay, but again, these are issues for once the vehicle has already contacted a pedestrian. We prefer no contact. You can make a softer hood, you can make a more compliant bumper, but you're still probably going to result in an injury. 20-year-old might be able to tolerate that injury. 80-year-old, most likely not. We also need to educate in the near term both pedestrians and drivers. As technology is refined and advanced, NHTSA will need to assess the need for more focused field assessments and investigations of the technology. As with all education programs that we put out there, we will have to evaluate those and adjust them over the course of time. That's both our short-term and long-term to try to influence the behavior. Now, technology. This is where we can make some significant inroads for reducing our numbers out there of injury and fatalities. Again, prevent vehicle interaction at all. Continue work on what we call PCAM, which is pedestrian crash avoidance and mitigation. And we also have work already in process for one of our safety standards, which is known as the FMVSS, Federal Motor Vehicle Safety Standard. Number 141 is currently under review by OMB and the Secretary of Transportation on cars that are like hybrid or electric that don't make any sound, that they actually have to produce a sound of a car going 18 miles an hour. Okay, that is currently what we've put out as our suggestion, or what the date, or not even our suggestion. That is the criteria by which we want our rules to be set by, and it's currently under review. PCAM looks at a lot of radar and camera-based systems that will identify a pedestrian as a car approaches. We're currently analyzing all this PCAM data that we're getting out in the real world and testing these devices and this technology, and hopefully we can eventually finalize in the long-term regulatory action. Now, depending on what we find out, the arrow in there from long-term to short-term is we might be able to, PCAM's moving pretty quick and there's a lot of push for it. So we're hoping that maybe finalization of regulatory movement will happen in the short term more than the long term. Another video. This is some tests that we're running, and this will be an animated pedestrian that we built as part of our work at NHTSA. And we're currently doing this. This is some of our near-term work. A 25-mile-an-hour approaching car with a, I believe this has a radar-based system, but we all have also tested the camera-based systems. And again, we have static and dynamic pedestrians that we've been using for our testing, but this is an animated dummy, a dynamic one. Let's see if I can get down here.
233, 25.
And no, the driver's not touching the brakes. It's all automated. So that's a 25-mile-an-hour approach speed with a radar-based system. Vehicle safety. All right, now we can roll, literally. As I said earlier, NHTSA's job for vehicle safety, and this is our next leg of our table, one of our columns. We set the safety standards for vehicles. If you don't pass those safety standards, you can't sell that car in the United States of America. Simple as that. So really, our safety standards come down to two areas. Crash worthiness, which are things like airbags, seat belts, crumple zones, chassis design, things of that nature in the car. That's crash worthiness side. There's also crash avoidance side, which is really coming on quickly with technology. These are things like you already have some of it in your cars, such as electronic stability control, ESC. Usually it's a little picture of a car with squirrely little lines behind it on your dashboard somewhere to turn it off. You really probably should never turn it off, unless you're going to the track and want to have fun. That's your call. But we put FMVSS 126 was put in place several years ago, put in as a rule in all cars by model year 2012. So any car made by 2012 and afterwards has to have ESC or cannot be sold in the United States of America. So any of you that have ESC on board and have hit some snow, have hit a wet spot, lost traction, whatever, and you hear some click, 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 but you don't go completely into a sideways slide into a tree or something like that, that's ESC working for you. Okay, great technology has made a world of difference out on the roadway. That's one that we have in place. Things that we're currently working on: forward collision warning, lane departure warning, blind spot monitoring, and automatic emergency braking. You saw that for pedestrian, but there's a whole nother area of emergency braking that we're working on. Now, crash avoidance in and of itself was not a core part of the plan. Although vehicle safety was, it really focused on crashworthiness issues. And the reason crash avoidance was not put in, there's about a paragraph about crash avoidance in the plan, is the fact that crash avoidance will benefit everybody. And what they really wanted in the plan were things that were going to be dedicated directly to older folks. So crash avoidance, although mentioned in the plan, has benefits for all ages, but it will have greater benefits for the older folks. There's no doubt about that. So a few slides on crash avoidance so that you guys know it's coming. We are working on it, but it's really not in the plan. Okay. Forward collision avoidance and mitigation, FCAM, kind of play on PCAM. Two parts of FCAM. One is DBS, which is dynamic brake support. What that does is that when the vehicle senses that you're on the brakes, but you're not on the brakes hard enough, it will increase the hydraulic pressure and get the brakes to where they need to be to stop what the radar or the cameras are picking up that you're approaching. Okay? And from the data, it looks like this is about 66% of the reason why front to rear end impacts are happening on the roadways. The other side is CIB, crash imminent braking. This is one where you haven't applied the brakes. You're not looking at where you're going, and the system picks up that you're going to impact the back of another vehicle, and it applies the brakes for you. That's about a third of the crashes out there, front of a vehicle to rear of another vehicle. So you put this in place, you take out 99% of the front to rear crashes by the data. We actually have DBS and CIB scheduled. It is the paperwork essentially is up to the Secretary's office for the next round of NCAP, which is our new car assessment program, our testing and crash testing and assessment of technologies of safety technologies in the vehicle, to be slated for the next revision of NCAP to add this in. So it'll be back upon the manufacturers to be putting this technology in the vehicles. Back to our pedestrian crash, again, we've come up with several different types of mannequins or dummies to put in our test. Dynamic dummies, moving dummies, still dummies, ones that run on sliders. One is actually walk. We have an array of them. There's a picture of several of them. We've done adult and small child dummies. We've corrected it for their visual appearance, their radar cross-section. We also are looking at, again, I've already said this, but we've looked at prototype systems of radar, video, and stereo video camera systems. So, again, back to PCAM. This is huge, and this is coming. Again, with crash avoidance, you'll hear a little bit more about this later today, probably from Ron Mefford's talk from Google. But V2V, vehicle-to-vehicle communications, one car talking to another automatically, one car knowing where another car is. NHTSA has the lead on this, and Federal Highway has the lead on V to I, vehicle to infrastructure. Okay? So a car would then know where a telephone pole is, or where an intersection barrier might be, or such things. So crash reduction through driver advisory, pre-crash warnings, or even possibly pre-crash activation within the car, such as automatic braking, which I just showed you. 2014, NHTSA put out an advance notice of proposed rulemaking, which said V2V is coming. V2V has the potential to address 80% of vehicle crashes by the data involving unimpaired drivers. Pretty huge if you think about it. But with that comes cybersecurity, an area we've kind of just now are getting into because we never had to worry about cybersecurity with a car before, but now we do. So if two cars are communicating to each other and somebody hacks that, we could have a potential issue. Okay, or think of an intersection problem at a major city or thoroughfare. So the Moving Ahead for Progress 21st Century, called MAP 21, put out by Congress, told us, you guys at NHTSA, you need to do something. You need to examine these issues and come up with some safety standards. Right now, we're looking at the interaction of electronic components with each other. We're looking at the security to prevent unauthorized access, and how other communication environments will interfere or interact with vehicle communications. We, as NHTSA, are scheduled to report to Congress this year on our findings on those three areas, and we're on schedule. But basically, work in cybersecurity is ongoing at NHTSA, and it is the next big deal for us to move towards V2V communications. V2V communications are great, but we have got to secure them, and they've got to be safe. And at the top of all this automation, of all this crash avoidance, you get to automation. And I probably should have said Ron Mefford's talk will probably be more to this slide. But you guys have probably heard of the Google car, drives itself. You get in and say, I want to go to the local supermarket or wherever, and zoop, off you go. You can read the paper. You can take a nap. You can play Candy Crush, whatever you want to do. More folks are, not just Google has these cars now, other manufacturers are coming up with their own. There are some technology hurdles to get over, but as you guys all know, technology hurdles don't last long anymore. There is a cost issue that needs to be dealt with, but with technology advancements, cost usually comes down. And acceptance. This is the United States of America, and certain people like their freedoms. You may have trouble telling some people, we'll drive for you. They'll probably tell you, I want to drive myself. But older population could be a great answer. Could be a great answer. Is it here today? No. Could it be in the future? Most certainly. Back to the crashworthiness part of the plan. There's only two parts of the crashworthiness part that we spoke to, and that's fragility, which is the age causes humans to their anatomy to be less tolerant. They're fragile. I put them with crystal. And then frailty. If you are injured as an older person, your ability to heal and get better and get over the insult you suffered from this injury is much more daunting, much more difficult than a younger, healthier person. Even an older, healthier person will still have trouble getting over injury. Frailty. We didn't do a lot in the plan with frailty because frailty is difficult. Frailty is one of these things that if you are old and if you have medical conditions, try not to get in a crash. Well, most people don't want to get in a crash anyway. But hopefully you let people know so they'll be at least a little more aware. Maybe they'll put a little more attention to what they're doing. It's just us trying to get the word out through the communication portal that I mentioned earlier. We are looking at data. We collect a lot of data on people in crashes and what their premorbid conditions are. So we get an idea, and we have outcome at baseline, 6 months and 12 months post-crash, so we can kind of get an idea of how well they did or did not do after sustaining certain injuries. We're trying to identify those at-risk populations that are more frail. Certain diseases probably do make you more frail. Short term, we try to get the word out. We're try to get some communication tools in place to inform the public better of those people who do suffer, who may just be older or may be older and have certain medical conditions that if you do get in a crash, your chances of survival are minimal, especially if you have certain ailments and sustain certain injuries. Long term, we're working on looking at advanced restraints, okay, to reduce load on people so they don't get injured in the first place. And based on our findings, we'll continue to try to push frail occupant awareness. Very difficult task. Very difficult to put your finger on that. But it's in the plan, and it's on our radar screen. Slightly more, I won't say easy, but more tangible for us to do is working with fragility. Okay, how frail is an older occupant? So in the near term, we're doing quite a bit actually with fragility. We're analyzing the current field crashes that we investigate, looking for the contributor factors and relating those back to the injuries sustained in the crash. We're testing what's known as post-mortem human subjects. The common name is a cadaver. Okay, we're using cadavers and crash dummies to evaluate sensitivity at lower crash speeds. So we crash a lot of vehicles and do a lot of crash testing at NHTSA. Yes, we do them with cadavers, okay? Yes, we do them with crash dummies. We do much more with crash dummies because cadavers, number one, public's not really always happy with that, even though we get great data from it and it goes a long way. But also, it's not easy to get a lot of cadavers. So we have limited testing with cadavers. But we are doing cadaver testing, and our crash tests are at 30 and 35 miles an hour for frontals and about 22 miles an hour for side impact, okay? At those speeds, the older folks not only are injured, but most of the time they're dead, okay? We need to see what the sensitivity of our tools, such as our crash dummies and our instrumented cadavers, can do at much lower test speeds. Will they react properly, okay? Do the crash dummies give us good sensitivity at these lower speeds? Do our instrumented cadavers give us good sensitivity at these lower test speeds? That's the things that we're currently working on right now. Again, we are looking at advanced restraints. We're looking at prototypes being put out by the manufacturers for reducing loads on the human body, okay? We are computational models. And I mentioned this earlier. We are continuing computational models. We've worked heavily in the area of the brain and head and the chest. Why? Brain injuries are very high frequency for the older folks, but chest injuries, as you saw, if you saw Jessica's talk, or no, Justin's talk, the second talk this morning. Chest injuries, very prevalent in the older folks. Breaking ribs, okay? Happens a lot. Why? Seatbelt rests right there. The ribs are fragile, okay, in the older folks. The problem is you don't die from broken ribs. You probably have heard this from the medical community many times. You die from what comes from broken ribs, which is typically eventually is pneumonia, okay? So you get older person with broken ribs, they go to the hospital, they languish in the hospital for a while, they get pneumonia, and they die, okay? So we got to reduce the load. So we're looking at advanced restraints. We're also building these computational models of the human body so that we can change our tolerances and change things that change with age with the human body so that we can run these models and have predictive analysis. And again, new car assessment went out for public comment in 2013, late 2013. They said, what does the public want to see in the next version of NCAP? One of the things came through was silver car rating. Having a rating for a car that has lots of bells and whistles for the older folks who are buying these cars. And that's one of the things taken under consideration after the comments came in from the public. A couple of things I just want to show you in looking at changes over time. This rolls into a lot of what we're working on. Contributing factors for why an older person gets injured. Work with the computational models. Work with new restraints and new crashworthiness technologies, okay? When we get to that automated car, it'll be great, but we're not getting there tomorrow. So this is the stuff that we're going to put in place. So right here on the far left, you have, if I can get my pointer working, this is a 20-year-old lateral picture of a C-spine. This will be easier, and this is a small room. Everybody hear me? Okay. These are your vertebral bodies, okay? Nice blocks. You see these blacks in between? That's where your discs are. You ever slip a disc or anything? That's where your disc resides, cartilage disc. This is what a normal spine looks like. You look in an anatomy book, this is the picture you're going to see, okay? Here's a 79-year-old spine suffering from ankylosing spondylitis, okay? All of these gaps have been boned together, okay? This, if I grab it, it's going to move and it's going to flex and it's going to extend, especially during a crash when you want to say yes emphatically, okay? You grow bone over all those joints. Okay? And for the man that taught me, it's like taking a piece of garden hose and a piece of terracotta pipe. Okay? But here's a 52-year-old gentleman we had. He's starting to grow bone at 52 years of age, and he has actually fractured through it here. Okay, back to how old are you when ailments start to affect you for a crash? 52, 79. 20 is what we build our models and our crash things in. Okay? So our dummy wants to move like this, and your 79-year-old occupant is not going to want to say yes emphatically. Computational modeling, what are we doing? We're looking at both experimental data, taking tissues that are older and testing them under strains and load conditions to get that information into the computational model. We're also looking at CT scans. On the upper far right, you can appreciate the first picture is of a teenager's chest and the angle of the ribs. And the next picture over is, if I remember right, it's about a 75, 78-year-old male who suffers from COPD. Does every elder person's rib cage look like the far right? No. But they also never look like the one on the left. They do change. Your rib angles change over time. I'm showing you basically both ends of the spectrum. But when you change those rib angles, you're also changing how your body can be loaded with, say, an airbag or a seatbelt. We need to be taking that into consideration. Things also change. Atrophy, okay? Your muscles get smaller. Your brain gets smaller, believe it or not, over time, okay? And that influences how things move and react during a crash. All things are taken into consideration for the computational models that we're designing. So, I wish I could have had the older model, could have shown you the older model. It's still not ready. This is our 50th percentile human male, healthy male. I'll run this for you in a couple of different crash configurations so you can see the model. But we're able to take this model, we're able to shave off down to different organs. We can get down to just a liver under a load condition. We can get down to certain bones. We can put the skin back on. All kinds of things that we can be done with this model, and we're currently building the older model. Side impact. with nothing but a door, essentially a door or a flat plane in place. Frontal loading with restraints, or I should only say belt restraint. And all of these ribs and muscles and everything, we can show the loads that are on those areas of the body. Rib fractures, side impact. What's known as a knee bolster, what a lot of people will call the dash of the vehicle, in place. Stripped off the muscles, you just have organs and bones. We can change conditions, we can change belt paths, we can change speed, force, just bony, bones, different views. You have an appreciation for lateral bend and deflection in the spine. So we're building this model for an older occupant. Yes, sir. I'd have to go back and look. This is just kind of an overall. I pulled this from about 5 different videos and stuck them together for today. I would say most of our stuff is probably is in the 20 range, probably, because you're not getting the big time whip of the neck. So I'd probably put those for the frontals are probably in the 20s. The side impact was probably crash speed, which was mid 20s. It looked more realistic. Yes, ma'am.
Excuse me, are you also crash testing female models?
We have the 5th percentile female. It follows behind the 50th male. So once we have because we build on what we have. So once we have the 50th in place, then we start building the 5th. We have the 5th dummies in place, and we're currently building a new 5th dummy. We have the Thor 50th, which is coming online, and we are currently developing the Thor 5th. We're doing the same for the models. It's all a matter of the amount of resources that we have. But we do know 5th is an issue. So back to fragility. What are we doing? Okay, you saw all the near-term work that I just mentioned. Short-term, next steps, expand computational modeling. Okay, we're doing the head and the chest. The next area, the big area of load, is through the femurs and the pelvis. So that's the next area we want to model, because a lot of your safety restraints that are built into the vehicle, both in knee bolsters and seat belts and airbags to some degree, rely heavily on the femurs and the pelvis to take a lot of load. So that's the next thing that we need to look at, because those things do change with age, just like all the rest of your body. The dummies and the crash dummies have what's known as injury assessment reference values. So the dummy can only see a level of so high of G-force or deflection or what have you in a crash test, or you fail. You don't pass the test. Well, we need to look at those IARVs for older people, okay? We have them for the 50th percentile and some for the 5th percentile, but we need to look at them for the older population. And we're currently we're planning on doing that work. I mentioned silver in-cap. So part of silver in-cap could potentially be those better injury assessment values. That could be a player in in-cap. We're going to continue collecting data on older occupants, because especially in like my group with Siren, we're seeing more and more what's coming through the door are older occupants. That's what we're getting. If we want a new car with a significant injury, it's usually an older person in that car. Again, long term, we're going to continue with modeling. We're going to refine injury criteria, and we're, again, developing those better restraints for reducing load on an occupant. The picture up there is, I believe, Ford's belt, which they have an inflatable belt, has an airbag within the belt that deploys upon impact. So that reduces load on the torso. Available, right now I know it's available in the Explorers as an option. It might be available in other makes and models. So this is the fun. You have a question? What's that?
I'll talk a little bit about it at 2 o'clock.
Oh, okay.
First available on the Explorer of 11.
Is that okay? I knew Explorer had it. We've gotten a couple in, but there's no injuries. I can tell you that. Thank you. So, and this is where I'm just going to show you some real world cases that we've taken in. 81-year-old female driver, 61 inches tall, 94 pounds. History of hypertension, osteoporosis, breast cancer with mastectomy. She's driving an older car, 03 Honda Accord, properly belted, did everything right. She ended up in the hospital for 3 days, but she did get to go home. She's sitting in a parking lot. Are we out of time?
Not yet.
Okay. Getting tight?
Yeah,
Okay.
we got
because we started a little bit late, yeah. So she puts the car in the wrong gear, comes out of her parking spot. Instead of backing out, she drives straight forward into the store she just shopped at, okay? But she only went about 10 feet. So if you take a look at her vehicle, she only scratched the left front bumper, the lower right picture. You can see the scratches on the bumper. You can appreciate that her airbag did not deploy because she was not going fast enough for an airbag to deploy. Her delta V was, her change in velocity from start to stop was 7.5 miles an hour. She has 6 fractures in her cervical spine from this impact. She has C3 through C6 spinous process fractures, which clinically are pretty insignificant, but she also has a 7th vertebral body fracture and a C6 lamina fracture, which are more significant. Basically, it's going to put her in a C collar for quite a while. C collar, anybody that's worn a cervical collar, it's no fun. You put it on an older person, you're almost guaranteed you're going to get some ulcers where it sits on the shoulder and on the neck. Basically, as I said earlier, she was emphatically saying yes, and it caused the fractures. Contributing factor is the fact that she's osteoporotic. And the behavior issue is that she got it in reverse. She put it in, instead of reverse, she put it in drive. And instead of getting on the brake, she got on the gas. Second case, 95-year-old male, 85-year-old female passenger, their husband and wife. Husband is 5'6", 180 pounds, pre-mortem history of cardiac artery disease and osteoporosis. The wife is 4'10", 109 pounds. She has cancer with mastectomy. She has reflux disease, anxiety, and asthma. They're in an 01 Civic, okay, and both spent 6 days in the hospital, and they were discharged to a nursing home. They went to get gas and get their car washed, okay? They went in, they got the gas, they came out, and the wife doesn't like, it's the wife's car, it's her Civic. She doesn't like to drive through the car wash. The husband says, I'll take care of it for you, hon. He gets in the car and drives it through the car wash. Main issue here, we end up with a pedal misapplication error. The vehicle exits the car wash, speeds up, loses, basically keeps speeding up. Instead of going out into the main road, the husband cranks it to the left, goes over and hits a parked truck. Damage is not that bad. You've got a 17 mile an hour delta V, not that significant of a crunch. But what we got going on here is the wife, because she's so short, has pedal extenders. She sits on a pillow because she's short, and she has her seat way forward because she's short. The husband changed none of this when he got in the car to drive it through the car wash. So he got a little mixed up on the pedals, put it in the side of a truck. He sustains C2 through C2, C3, C4 fractures, T6 fracture, L1 spine fractures. He was unbelted because they usually wear their belts, but they're just going through a car wash. When they get on the other side of the car wash, they're going to get out and switch positions to go home. Unfortunately, they didn't get to go home. They went to the hospital. So he fractures his cervical spine. He also gets a cord injury that does eventually resolve, but he did have paralysis short term. He also degloves all the skin off the top of his hand by contact to the windshield. The wife, she doesn't fare a whole lot better. She ends up with rib fractures on the right, 3 to 5 from impacting the door because she's unbelted. And she also shatters her right upper humerus due to contact to the door. Third case, last case, so you guys can wake up. 2 91-year-olds, husband and wife again. They're in their 2013 Volvo XC60. Okay, Volvo, most of you know, prides itself on safety, and they do it well. They're all belted. They're all doing what they're supposed to be doing. The female is the right front passenger. Her husband's a 91-year-old driver. We're going to concentrate on the passenger. The airbags deploy as they should. Everything works out well. She spends 12 days in the hospital. She discharges to a hospice and after 60 days succumbs to her injuries. She will not be a FARS case because she made it more than 30 days. So FARS says that you did not die because of a car crash. You died because of something else. The scene is intersection. They were not at fault. Okay? The vehicle coming from the top down for you guys, hitting our red vehicle at the bottom. It's a front side impact, which you call an L or a 7. Is the person at fault. Younger driver, actually. Moderate vehicle damage. The damage is not that severe to the vehicle. It was enough damage, enough change in delta V to fire the bags. Okay. We had 12, but what we have is with this frontal impact, you have both longitudinal forward and lateral side changes in velocity, okay, which is key here. So your occupant kinematics are not forward built for the test. They are forward and biased inboard, or for the driver, outboard. But our person we're interested in is the passenger. So what's going on here? Why did she get injured so bad? In a well-restrained, optimal setup with a car that is very well built. She ends up with 16 rib fractures. She breaks basically every rib she's got, with the exception of a few. And it's all from loading the belt, and she's osteoporotic. She also fractures her sternum, your breastplate. Okay, and there was melted webbing showing how hard she loaded the belt. She melted the vinyl on the webbing. She also had an open fracture of her ankle. We learned from her husband that she always traveled with her right over her left foot crossed. So she ended up loading what we call the transmission hump, that ridge in the middle of your car where the drive shaft for rear-wheel drives used to go through. Her leg went over there because, remember, she's going a little forward but a whole lot sideways. She wants to go over towards that steering wheel in this crash. So she actually shatters her ankle pretty badly. You can appreciate all the yellow arrows for all the fractures in her right ankle. And this was an open fracture. The bones came out through the skin. She also fractured her arm on the shifter in the mid-console because it was displaced. And again, this is not a very big crash, ladies and gentlemen. So what's going on here? 16 ribs, and eventually fatal. Was it her size? She's little. Was it her age? She's 91. Is it the crash? It's actually all. So what's NHTSA doing? Let me go through this real quick. We're coming up with a test. We're currently working on a test. What you see on the far left is running our car into a wall. That is our current frontal test. And we have a crabbed vehicle barrier that moves into the side of a stationary vehicle. That is our side impact test. And what you see on the far left is the oblique test that we're currently working on. Now, this test is not exactly the same as the test the crash I just showed you, but it generates the same type of kinematics and the same problem, which is inappropriate restraint loading. Here is an oblique test on a 2013 XC60. So it's just fortunate that we have a field case and we have the car in the lab. When it gets to showing the interior and the dummies, key on the right front passenger. And take a peek at the driver too. It'll probably help you figure out the outcome here. This is a much more severe crash than this one. This is a 35-mile-an-hour Delta V. That barrier approaches this static vehicle at 56 miles an hour. Key on your dummies and where they go. Key on the shoulder restraint for the right front passenger. Should be one more close-up. So, belt doesn't stay where it's supposed to stay. It comes off the shoulder. The head doesn't get, you don't get any ride down from the airbag because you're missing it. Okay? The crash that the real world crash that I showed you, she would have had even more, because it's more side impact than front, she would have had even more bias to even miss the bag. She probably didn't even touch that frontal airbag. She just got a solid load of belt to her ribs, resulting in 16 rib fractures. So as I said, this is both not only an occupant issue, this is a crash issue, this is a restraint issue. Our goal is to marry crash avoidance and crash worthiness going forward. Optimal protection for older occupants is what we're working on. Crash avoidance has great potential to pull this all together and eventually get us to a point where cars aren't contacting each other anymore, but we're not there yet. If you can't avoid the crash, then we want to lessen the loads that the occupants inside the vehicles are seeing. And again, that's what we're working on. Let me knock out the last slide and you guys can go crazy on me. We've got a growing population. We know that. We're living longer, staying mobile longer. We already heard that this morning. NHTSA has developed a 5+ year plan for transportation safety for this population. The 4 pillars: data, behavior, pedestrian safety, and vehicle safety. The plan is heavily dependent on what we have for resources and our current program findings and accomplishments. Cooperation and communications with the state safety program offices and the states themselves is going to be key, especially on the behavior side and getting the word out. Properly harnessing the emergency technologies, especially for crash avoidance, is going to be very key. And balancing, as I said just a minute ago, avoidance and crash worthiness for the entire population will have huge benefit for our older populations. Thank you.
Thank you very